Hello guys, this is the map tutor, and in today's video I'll be solving this problem. Let's do it. There are two rowboats, boat 1, boat 2 at rest with their sterns together. They are colliding basically. There are two boys each sitting in one boat. The boy 1 in boat 1 has a mass of 1. So let's call that mass 1, and we know here is 240 kilograms. Mass 2 is 160 kilograms. Let's do a diagram of the problem. We have a boat here and another boat here. There's a guy here pushing the boat with a paddle. And there's another guy here, and he's like, "Hey, why are you moving my boat?" What else? We know that they start from rest, so the initial velocity is 0. And we know the overall time. Overall time. Overall time is 1.5 seconds. We also know the velocity of boat 2 is 0.9, but we don't know the velocity of the first boat. It's not 0. We don't know it. We are looking for it. And we need that because the first question is to determine the speed v at which the two boats are moving away from each other. So that is basically the total speed. And the total speed is the sum of both speeds, velocity 1 plus velocity 2. But we lack a velocity 1. How do we find that? We can find that using the equation of momentums, of the conservation of momentums. The momentum before the collision of boat 1 plus the momentum before the collision of boat 2 will be equal to the momentum after the collision of boat 1 plus the momentum after the collision of boat 2. So this is the equation. But this is 0 and this is 0 because both boats start at rest. So there are no momentum. So this is equal to 0. And we can replace the momentum with the formula of momentum is mass times velocity. Mass 1 times velocity 1 in vector form plus mass 2 times velocity 2 in vector form. It's equal to 0. And how do we change the vector form to have both scalars to get the speed in the scalar form? We observe the directions. The second boat is will move after the collision to the right, and the first boat will move to the left. Left is negative, right is positive. That is the convention here. So this is negative, this is positive. Let's represent that. Mass 2 times velocity 2 minus mass 1 times velocity 1 is equal to 0. We're looking for velocity 1, so we clear the variable velocity 1. Let's do that. Velocity 1 is equal to minus mass 2 times velocity 2 over minus mass 1. We replace all of those variables on the calculator. We get the number 0.6 meters per second is positive because both signs, negative signs, they become positive. So we're looking for the total velocity, and that will be equal to 0.6 meters per second plus 0.9 meters per second. And that is 1.5 meters per second. That is the first question of the problem solved. Now we have to find the force applied by the boy. Force is equal to mass times acceleration. So we are looking for the acceleration. So what is acceleration? Acceleration is velocity. We can find it using this formula. Velocity is equal to initial velocity plus acceleration multiplying time. But the initial velocity is 0. So we can clear the variable acceleration. Acceleration is equal to velocity over time. That's the one we're going to replace in the formula of force, mass times velocity over t. But the real question here is which mass? Mass 1 or mass 2? Velocity 1 or velocity 2? So the magnitude of the force applied to the boy is moving what? In applying to the other boy. So it's applied to the second boat. It means we have to use the mass 2 and the velocity 2. That's what we're going to replace to find the force on the calculator. Do that. Use these numbers. Do that by yourself, and you will end up with 96 newtons. That's the force. Then we have to determine the change of distance between the boats when the boy was applying the force. And how do we find that? We use the formula of distance. Distance is equal to initial velocity multiplying time plus acceleration times time squared over 2 velocity. Initial velocity is 0, so x1 will be equal to, we replace the value of the acceleration we find before. We replace with velocity 1 over time times time squared over 2, and we kill this squared, we simplify this time, and we end up the distance 1, the distance that the boat will move will be equal to velocity 1 multiplying time over 2. So we can do the same with the second distance. That will be equal to velocity 2 times, multiplying time over 2. But we are looking for the total distance, the change of distance between the boats, both boats. So we again have a total number, in this case for distance. So this is x1 plus x2. And we can replace, but we have the time, which is 1.5. We have the velocity 1. We already find that 0.6. We have velocity to 0.9 multiplying time. So we can replace all the numbers. And that is equal to the total distance will be equal to 1.125 meters. That's the total distance. Put that on your calculator. Do that by yourself. We have to find also the work done while the boy was pushing. So what is work? Work is equal to 1/2. We can represent work as being the sum of the total kinetic energy in the system. And in this system, we have two objects, boat one and boat 2. So let's represent that. The kinetic energy of boat 1 plus the kinetic energy of boat 2. So the work done will be equal to, using the formula of kinetic energy, is 1/2 of mass 1 times velocity 1 squared plus 1/2 the kinetic energy of boat 2 mass 2 plus velocity times velocity 2 squared. And again, we have all those numbers. This is 0.6, this is 240 kilograms, this is 160 kilograms, this is 0.9 meters per second. We replace all of that in the calculator, and we finally get that the work is 180 joules. That's the unit of work. So finally, what we end up in the last question, to determine the ratio between the kinetic energy of the two boats. So the ratio can be, we put the one that is higher, and the one is higher is this one, because these numbers are higher. The second mass is higher. So let's put that 1K1 times over, the kinetic energy of the second boat will be equal to velocity 1, 1/2 of mass 1 velocity 1 squared over 1/2 of mass 2 velocity 2 squared, and that is equal to 2/3. So this one is bigger, but the ratio is all right. So that's all the problem.